9C, we're going to test the difference between two means. Okay, so we have two different samples, and we're going to see if there's a difference between the means of those two samples. Sorry if you heard any strange splashing noises in the background. My dog decided that now would be an appropriate time to drink water as loudly as possible. So here are steps. Okay, again, this looks familiar. All hypotheses, identify the alpha. We do have to decide whether it should be a t-test or a z-test, and we're going to look at the conditions for that and then use your graphing calculator to find p, just like we've been doing for the last 2 units. All right, so deciding between the two tests. Okay, same rules as before. We're going to use a z-test if both sample sizes, because remember we're looking at 2 samples, both of them are greater than or equal to 30. All right, or if both population standard deviations are known. This is kind of a rare case. Usually you're given sample standard deviations, and remember those are marked by S, so we'll say like S1, S2. But if for some reason you had a small sample size, but they gave you population standard deviations, you would use the z-test. For the t-test, that would be if one or both of our sample sizes are less than 30 and both populations are assumed to be normally distributed. So the problem will have to say, assume the populations are normally distributed. If it doesn't say this, then we can't do any test at all. Okay, so let's look at an example. Researchers want to compare average salary for teachers in Georgia and Ohio. So they took a survey of 200 teachers in each state. And here they have the mean salary for both and the standard deviation for both. So let's go through our process. So null hypothesis, alternative hypothesis, okay? Conclude that the mean salary for teachers in Ohio is higher than Georgia. All right, I'm going to call Georgia, well, they call Georgia 1 and Ohio 2. So the claim is that the mean for 2 would be higher than the mean for population 1. We usually write 1 first, so I'm going to reverse this and say mean 1 is less than mean 2. Okay, that is the claim. Because the claim does not have an equal sign, it's going to go into the alternative hypothesis. So in my null hypothesis would be the opposite. The opposite of less than is greater than or equal to. Okay. Our alpha is 0.01. As for which test to use, our sample sizes are 200 for each. So that means I'm using a z-test. So let's look at the calculator steps for a z-test. All right, very similar to what we've been doing. Okay, and then here is the things that we need to enter. We have to choose the alternative hypothesis. We have to put in the sample standard deviations, the sample means, and the sample sizes. Okay, so calculator, I'm in the stat menu already. I'm going to go to test, Z, and it's 2 samples, so 2S. All right, mine says list right now. I'm going to change it to variable. Okay, our alternative hypothesis is that mean 1 is less than mean 2. Yours might say S here or SX. This is the standard deviation. So our standard deviation for Georgia was 6935. Our standard deviation for Ohio is 6584. The X bar 1 is the sample mean. So our sample mean in Georgia was 49,900. Our sample size in Georgia was 200. Our sample mean in Ohio was 51,900, and our sample size for that one was also 200. Okay, execute one more time. Calculator gives me all this information, including a p-value, e to the negative third, so I'm going to put 2 zeros in front, so this is going to be 0.002. Okay, so my p-value is going to be 0.002. My alpha is 0.01, so those two that is less than. All right, so that means I am going to reject the null hypothesis and say I have enough evidence for the alternative. All right, so we reject the null because, again, I'm going to abbreviate, P is less than alpha. So our claim here was in the alternative, and that's the one we have evidence for. So there is enough evidence to support the claim that the mean salary for teachers in Ohio is higher than teachers in Georgia. Second example that we are going to look at. So we're looking at some statistics for annual earnings, okay, between people who have a high school diploma and people who have a bachelor's or higher. Assume the populations are normally distributed and the population variances are not equal. At alpha equals 0.01, is there enough evidence to support the claim that there is a difference? Okay, so claim is that there is a difference. All right, so that would mean that mean 1 is not equal to mean 2. And then the opposite of that would be in my null that mean 1 is equal to mean 2. Okay, we have our alpha of 0.01. Our sample sizes are 15 and 12. And the populations are normally distributed. So that means that we can use a t-test. So here are our steps for a t-test. All right, again, same things. One big thing I want to note here is at the bottom, when you get through typing in all of this stuff, the calculator will say pooled. Okay, pooled should be, and the choices are on or off. Pooled should be on if the population variances are equal. Pooled should be off if they are not equal. That information must be given to you in the problem. So in our example here, it says the population variances are not equal. So that would mean pooled will be off. So let's go to the calculator. All right. So test, it's a t-test and a 2-sample t-test. Okay. So our hypothesis is that mean 1 is not equal to mean 2. All right, our first average is 27,136. And then our standard deviation, yours probably says SX. This is a weird version of the calculator. So our standard deviation here is 2318, and our sample size is 15. For population 2, the mean is 34,329. The standard deviation is 4,962, and the sample size is 12. And then pooled here is going to be off because the variances are not equal. If it said they were, we would change this to on. So you have to pay attention to that for the t-test. And then we run our test, and I get a p-value here of 0.000. All right. So my p-value rounded to 3 decimal places is 0.000. My alpha is 0.01. P is less than alpha, so we are rejecting the null hypothesis. We have evidence to support the alternative. The alternative is also where our claim is, because a claim is that there is a difference. Okay, so my conclusion sentence here would be we reject the null hypothesis because P is less than alpha. So there is enough evidence to support the claim, all right, that there is a difference in the mean annual earnings based on level of education. And we are all done.